Okay, so we are living on a neutron star, and we tune the local station. So the frequency of the station is 91.7 megahertz. Okay, but we tune it in at 90.2, right? So we hear it at 90.2. So let's think about this. We hear them going slower, right? Than they really should be going, right? So low clocks run slow. So they are lower than us, or we are higher than them. So let's draw a picture of this. This is us. This is them, right? We hear it at 90.2, right? So they're a low clock. They're running slow. And the reason for this is, of course, these photons are climbing out of that gravity well, right? The energy of a photon is HF, right? Okay, and as they climb out, they can't go slower because they're light particles, right? So those photons are losing frequency as they climb out, and that's what this formula calculates, right? Okay, so notice the difference between this. Our change in frequency is 1.5 megahertz, and that's just this guy minus this guy gives us 1.5. So we can set up this equation here. So we're going to go 1.5 over, and the actual frequency is 91.7, right? These are megahertz. And then that equals G, which we're trying to find, right? Our height is 35.6. And then C squared is 3.00 times 10 to the 8th squared. We can do this. I can do this. Okay, so 1.5 divided by 91.7 times 3e8 squared divided by 35.6. And I get 4.13. Really, it would be 4.14, I think. I get 4.135. So I'm going to go 4.14 times 10 to the 13th. And that is newtons per kilogram. Okay. Now, since we see them going slower, they are a low clock, so we are higher than them. Okay.